This is Chemistry with Chris, our online chemistry class. We are still looking at gas laws. Gas laws. But in today's lesson and teachings, we are looking at Dalton's law of partial pressure. We are looking at Dalton's law of partial pressure. Dalton's law of partial pressure states that the total pressure exerted by a mixture of gases which do not react chemically is equal to the sum of the partial pressure of the constituent gases. Dalton's law of partial pressure states that the total pressure exerted by a mixture of gases which do not react chemically is equal to the sum of the partial pressure of the constituent gases. Stated in another way, Dalton's law of partial pressure states that a gas will exert a pressure as if it alone is left in the container when it's with other gases. That is, in a mixture of gases, a gas will exert a pressure as if it alone is left in the container. That's another way of stating Dalton's law of partial pressure. The first way to state it, Dalton's law of partial pressure, states that in a mixture of gases which do not react chemically, the total pressure is equal to the sum of the partial pressure of the constituent gases. But it can be stated in this other way. In a mixture of gases which do not react chemically, a gas will exert a pressure as if it alone is left in the container. One important use of Dalton's law of partial pressure is correction of gases that are collected over water. We are still going to look at example of such. Dalton's law of partial pressure is oftentimes used for correction of gases that are collected over water. Now, what does the law mean? Now, if you have a container, this is a container. Then in this container you have gases, various gases. Let's say you have gas A, B, C, D, and E. The total pressure in this container will be the sum of the partial pressure of all these gases. That is, P total will be equal to partial pressure of A plus partial pressure of B plus partial pressure of C plus partial pressure of D, then plus partial pressure A, B, C, D, E, plus partial pressure of E. That's what the law says. The total pressure in this container now will be sum of the partial pressure of the constituent gases. That means this gas A will exert a pressure on this container as if it's the only one that is in this container. This gas will exert a pressure in this container as if it alone is left in the container. That is, to now get the total pressure in this container, it will be the sum of the partial pressure of the constituent gases. But when the gas is collected over water, that's one of the importance of Dalton's law of partial pressure. That is for the correction of gases that are collected over water. When the gas is collected over water, it means that the gas is prepared in the presence of water. That means water is mixed with it. Then in that case, to find the total pressure, your total pressure in that case will be partial pressure of the dry gas plus partial pressure of H2O. When the gas is collected over water, the total pressure in the container will be partial pressure of the dry gas plus partial pressure of water. So partial pressure of gas plus partial pressure of water. That means to get the partial pressure of the dry gas now, the partial pressure now of the dry gas will be equal to total pressure minus partial pressure of H2O. So this is what Dalton's law of partial pressure states, and these things are important in calculations that we are going to bring your way in the next episode. If you are new to our channel, subscribe to our YouTube channel at chemistry with Chris. We also have physics with Chris and maths, which is also ditto as further maths with Chris. See you in the next class for examples of questions on Dalton's law of partial pressure. Bye.